Alright, hello everyone. Welcome to Fijit's Academy. So I am Mr. Baljit. So let us discuss today about how to answer IGCSE questions. So for today, I will be focusing on one of the papers of the past year papers, which is May-June 2018, variant 4.2. I'll be focusing on today's, which is a theoretical paper 4 for extended students. For students who are taking extended papers, so they will be doing this paper. Right, let us go for the how to answer the first questions. So most of the times, the first question will be related to some forces and motions. Right, let us directly go into the questions. So it is advised that every time when you are doing the questions, make sure to read through the whole questions first. This is for you to get the whole picture of what the questions will be asking you about. So we can see that here in question number 1A, so the questions is related to a distance versus time graph where a student is required to draw the graph. So of course, the information will be given on how you're supposed to draw the graph. So the information is given by the information down here. And then state the property of the graph, which represents the speed, right? And then it continues about understanding acceleration and relating acceleration to the distance time graph that we have up here, right? And then calculating the acceleration itself. And then we come into the next type of graph, which is a speed versus time graph, right? And also there will be a drawing that a student need to do, and how can we actually draw the graph, at the same time how we can actually calculate the distance travel. So when it comes to these kind of questions, it is very important that students are clear about the concepts that comes with the concept that come with the idea about graphs. So let us go into the question. So in figure 1.1 shows an axis of distance versus time graph. So always highlight the important keywords and important informations. Okay, and the object is moving in a straight line. So in IGCSE, they only cover motions in straight lines. And the most complicated will be motion in a circle, which is just an introduction of circular motions. Okay, so the students is required to draw the graph. So let us see. So on figure 1.1, draw between time 0 seconds and up to time 10 seconds. That means up to this time here. The graph of an object moving with constant speed. So according to the theory, when you have a constant speed, if you want to have a constant speed graph based on a distance time graph, how do you calculate the speed? Speed will be given by gradient of the graph. So in this case, for you to have a constant speed, means the gradient must be constant. So if the gradient must be constant, that would mean that the graph should be a straight line increasing graph. Okay, increasing straight line graph. Right, that means in general, we can actually kind of sketch the graph. So it's supposed to be distance versus time. So it's supposed to be a straight line graph like this. Because it starts from 0, so you can start the graph from 0. All right, so for them to have a constant speed of 5, so that means the gradient of the graph must be 5. Okay, so that means you have to create a graph. So you know the initial point is 0, 0. So you have to find another point which can give you a gradient of 5. Right, the gradient of 5 for this graph. So we know the time is 10 seconds. Right, that means you just need to find the value of the distance here. Right, it should be somewhere along this line here, somewhere along this dotted line. But at which point or at which distance? So we don't know at which distance it will be. So we can use the gradient concept. So gradient, which is also equals to the speed. Right, according to the gradient formula, it should be d2 minus d1 over t2 minus t1 equals to the speed, which is 5. So D2 we don't know, D1 we know, it is a 0 coordinate. So D2 we don't know, D1 we know. Time we already know it's 0 seconds until 10 seconds, so it should be 10 seconds. Or you can do 10 minus 0, which is equals to 5. So this will lead you to D2 equals to 50. And D is a distance, so 50 meters. So your next point should be somewhere here. So what you can do now, you can actually draw a straight line pointing up to this point, and you have fulfilled the requirement of the question, drawing a constant speed line on a distance versus time graph. So earlier, I have mentioned that the property of the distance time graph that gives you the speed, which is the gradient. We already seen it here. Gradient must be constant. The gradient is the speed. So here, you can just write down the gradient. Now, it is important for you to have the concepts. When you know the concept, you just need to apply the concept onto the question. So let's see the next part of the question. So between 10 seconds and time 20 seconds, the object accelerates. 10 seconds and 20 seconds. So the 20 seconds is not given in this part of the graph. So acceleration. So in this case, we have to highlight the term acceleration, because when it comes to acceleration, according to the theory, when we learn about the graph of distance versus time, and when object is accelerating, means speed is increasing. Right? Based on the idea of acceleration, speed is increasing. And from the distance versus time graph, if the speed is increasing, that would mean that the gradient of the line, or you can imagine it as the steepness of the line, increases. So that would mean that it should be a curve graph. It should be a curve graph. Curved line. It shouldn't be a straight line anymore, because straight line will give you a constant gradient. So the gradient which is increasing is supposed to be a curved graph. So a curved graph with an increasing gradient will be something like this. That means the steepness of this line is increasing over time. Okay. So let's see now. So between 10 to 20 seconds, the acceleration, the object is accelerating. The speed at the time 20 seconds is 9. And what was the time at t10 second? At t10 second, the speed was, as we have calculated, 5 here. It was shown by the question itself. Constant speed up to 10 seconds. Right? So that means up to 10 seconds, the speed is 5. After 10 seconds, the speed increases to 9. So according to the idea of acceleration, acceleration is always the change in the velocity divided by the time taken for the change in the velocity. So the velocity changes from 5 to 9. So final velocity minus initial velocity, which is 5, divided by the time taken for the change, which is 20 seconds minus 10 seconds. It takes 10 seconds to change the speed. So you will get 4 over 10, which will lead you to 0.4 meters per second squared. So that will be your answer for this. So you can put it as meter second minus 2, or the unit can also be meter per second squared. It's up to the student how they want to use the indices. Okay, let's go to the next question. Next question is related to the speed time graph for a different object. So now we are talking about a different object which is moving with a different speed, different movement and everything. Okay, so the object has an initial speed. Initial speed, that means when you start your timer, when the time starts, the object has already a speed, right? And then the object starts to decelerate uniformly. When they say decelerate uniformly, that means the speed decreases at a constant rate. Okay, it is decreasing, but decreasing with the same value all the time. Okay, and the rate given, the deceleration given is 0.35 meters per second squared. So a student must always remember that whenever they are giving you the value of deceleration, it should be a negative acceleration. Deceleration is equals to negative acceleration. Okay, let me move it slightly forward. Okay, deceleration is equals to negative acceleration. So you have to bear in mind about this. All right. So why I say I'm stressing on this is because when it comes to calculation, the value for the acceleration must be put as a negative value if a calculation is required. Okay, so let's see now what the question wants us to do. So on figure 1.2, draw the graph represent the motion. Okay, so you know the deceleration is negative 0.35 meters per second squared. You know the initial speed. Okay, so what are the information that we have? The initial speed we have, which is 50 meters per second. We have the deceleration, negative 0.35 meters per second squared. And initial speed is 50 and decelerate uniformly for 100 seconds. So that means it starts from 50, it decelerates all the way uniformly for 100 seconds. So we know the time itself, which is 100 seconds. Okay, so according to the deceleration or acceleration formula, final velocity minus initial velocity over the time taken. So we can put in the value. Final velocity is 0. No, we don't know what is the final velocity. We know it decelerates for 100 seconds, but we don't know what is the final velocity. So it's not given, it's not mentioned in the question that the object is finally at rest. So they just say there is a deceleration. So we don't know the final value, but we know the initial speed of it, and the time taken is 100 seconds. Right? So that would mean that, so we can move it. So negative 35 will be equals to V minus 50. So V will be equals to, you move it over 15 meters per second. So the final speed of the object is 15 meters per second, which is here, 15. And it takes 100 seconds to reach to that speed. So 100 seconds, so here. So that will mean that you can actually create, because it is a uniform deceleration or constant deceleration, so you can draw it as a straight line joining the initial speed and the final speed. So again, remember, the question never mentioned about the speed of the object is 0 at the end. Since they never mentioned, so we cannot guess the value. So we have to calculate the value. So the calculation is shown here. So this will give you the full 2 marks. Okay, drawing the line and also having the value of 15 meters per second squared shown here. Okay, next, the question asks about the distance traveled. So for the distance traveled, according to the concept, okay, according to the concept, when you have a speed time graph, okay, to calculate distance, distance is calculated by using the concept of area under the graph. Okay, that is the concept. So let's see what area do we have under this graph here. So if you notice that the area that we have under this graph here is actually an area of a trapezium. Okay, if a student can visualize it, it is a trapezium. Or you can also look at it as two different areas, which is one is a triangle up to 15 here, On the above part here is the triangle, and the bottom here is the rectangle. So it's up to the student how they want to visualize this. So I would prefer to look at one shape itself, which is the trapezium. It means I have to know the value of or how to calculate area of trapezium using the formula of area of trapezium, right? Because the lesser calculation you do, the lesser errors that the chances of errors to happen. Okay, so since we know that, so distance traveled will be equals to area of trapezium. So area of trapezium is given by 1/2 times the two parallel sides added on. So the two parallel sides will be this side and also this side, which is 50 and 15. This value here is 15, and the whole height here is 50. So 15 plus 50 multiplied by the height of the trapezium, which is from 0 until 100. So 100. So simplifying this, so you have 65 times 50. Which will lead you to 3250 meters. So as an answer, you can write it as 3300 meters because this is in two significant figures. Or the answer as 3250 will also be accepted because this is in three significant figures. Right, so that will give you the full 9 marks. Right, so I hope that this question and my explanations are clear for you to guide you for your IGCSE. So if you please keep on following me for more discussion of more questions. Thank you so much.